There are special engineering challenges unique to big data, but unfortunately, big data is rather nebulous, or at least the definition of it. Here, we will define big data as it is used by practicing experts. Big data are data that are unprecedented in scale and scope in relation to a given phenomenon. We are often saddled by limitations of how much and what kinds of data we can collect. Take, for example, data collection from surveys. Survey data is often limited in that we could only ask certain questions to a small number of people relative to the entire population. If we could instead survey the entire population and know things about them that surveys do not tell us, such as social behavior, we have effectively transformed our data into big data. Big data are things that one can use at a large scale that cannot be done to a small scale. This is analogous to the survey data example. This also means being able to do analytics on a large data set that would normally require us to take smaller samples in order to analyze, or the computing power of our environment. Big data means we can look at all of our data. We will examine the boundaries of big data using the 3 V's, volume, velocity, and variety, which we will discuss next. Later modules, however, will discuss more nuanced definitions of big data, but we will walk before we begin to run. So the first V is volume. It is simply the amount of data that you have, and this data could either be static or dynamic. It is often measured in terabytes or even petabyte type of scales. Companies like Facebook, Google, Yahoo store data on the petabyte scale. To give you an idea of the sheer size, as an example, a song that lasts 4 minutes, a petabyte worth of these songs would last over 2,000 years if played continuously. Once you get into the terabyte and petabyte scale, no single machine can contain that amount of data or do compute over that amount of data. The data must thus be stored across multiple machines in what we often call a cluster. The second V is velocity. Data we are interested in often has some dynamic elements to it that must be tracked over time. This means our data is constantly being updated in real or near time and on a frequent basis, such as hourly, daily, and so forth, even down to the microsecond. This data can come to us in a variety of different formats, but they're coming in, the emphasis on velocity is that they're coming in quickly. Velocity and volume, as you may suspect, are often hinged together. If you're getting data in at a very high velocity, it's very likely that you're going to accumulate large volumes of data. But to give you an example of big data velocity, Twitter receives over 500 million tweets every day that it parses, analyzes, and then stores. Such a high velocity of data requires unique engineering to capture all of the data. Just like no one machine can contain large amounts of data, no single machine can capture a fire hose of incoming data. A high velocity data source often contributes again to high volume. Finally, we have variety. Data can come from a huge variety of sources. For example, we may want to combine weather data with sales data to help predict when revenue will peak or slump, or maybe different departments keep different data from their specific products or customers. Data can be structured or unstructured. Structured data is maybe what we're used to seeing in nice Excel files with fixed columns. This type of data typically has a rigid structure, and we expect to find data in all records. Unstructured data, however, is a little more fluid, and separate records may not contain the same information. Most text data, for example, is unstructured, since text length and word content can vary, not only from record to record, but also depending on who wrote it. Other examples include traditional spreadsheet data, web traffic logs, photos, videos, social media data like Twitter and Instagram, and many others. It is important to note that all 3 V's can contribute to the size of your data. The huge velocity of the data can generate to huge volumes of data, and likewise for variety. So let's talk briefly on what big data is not. First, there really is no quantifiable amount of data that determines whether you have data and met some artificial thresholds. When most people think about big data, they think about data that is so large it has to be stored on a cluster. But big data is relative to your problem domain and depends on the three V's. Furthermore, I would encourage you to think about the three V's as using this OR operator. That is volume, velocity, or variety. Any one of these can and will present unique problems. All three of them, of course, present sizable, though surmountable challenges. Different companies have different use cases and obviously different data. A solution that works for one company may be ineffective or completely wrong for another. So while it is valuable to learn from others, understand what their motivations are that ultimately drove their technology choices and the analytics by which they used to sort of capture the true sensitivities of their business. Learn, replicate where it makes sense, but above all else, understand your business drivers for the application of big data. In other modules, we will discuss some of these business aspects more comprehensively. This section, however, will focus more on the technology aspects. Many times, people will equate big data with data science. Unfortunately, this stems from the misunderstanding of what data science is. Having big data is not a prerequisite for data science. In fact, most data science is done on smaller data sets. An easy way to think of this is big data is a resource. Data science is a methodology. The marriage of the two is often very effective, but big data does not always equal big results. The trend toward big data is often sensitive to data science, however, which it ought to be. These overall trends are very different than this IT view of data as a mere workload. Data, as it turns out, is a resource for most organizations. Those of whom choose to ignore this run the risk of losing gains in the market and ultimately future cash flows. Finally, big data is not guaranteed to solve all of your analytic and business problems. Data is a resource that can be refined into insights. Bigger data is not necessarily better data, but data usually is always better than no data and the application of raw intuition to solve our most pressing business problems. In the next section, we'll discuss the factors when deciding what your big data needs are.